Hello, welcome to Channel 9 Live here at Microsoft Ignite in Chicago. I'm Matt McSpirit, technical evangelist for all things data center. Now don't forget, you can interact with us in this session. So if you're on the Twitter, tweet us at hashtag MSIgniteCH9. And if you want to interact with us directly through questions, also go to the channel9.msdn.com website. You'll see a little form under the video which you can complete and send us your questions in, and we'll make sure we try and answer as many of them as we can. Now, as part of the keynote you saw, or hopefully saw earlier in the week, there was a lot of talk about security in Windows Client, in Windows Server, and the whole infrastructure. So obviously, it's very, very important. Now, who better to talk to us today than somebody who lives and breathes security? It's Anders Wimberg, Technical Fellow in the Windows Server Cloud and Enterprise Group. Anders, welcome.
Thank you. Thank you.
I've got a load of questions that I want to ask you,
all right,
all related to security. You'll find them very easy, don't worry. But it's all good stuff. It's all important stuff that our IT pros need to know. So when it comes to security, everybody knows it's important, but what does today's threat landscape look? What are people facing within their infrastructures? And what are some of the landscape shifts within the data center that are influencing and bringing about change?
Yep, the situation is really changing dramatically. All you have to do is read the newspaper. We're not talking about teenage hackers anymore. We have organized crime, extremely active. I read recently an estimate that cybercrime is now a bigger business than illegal drugs. But you also have nation states who are doing attacks, and there is IP theft, industrial espionage, and a lot of really high-profile companies have been hit, and hit hard recently. And if you look at them, they were competent people. They had good security practices in place, and they were taken down anyway. So we should all be afraid. Now, a bigger change, though, or a bigger impact perhaps for all of us, are the technological changes in the landscape. Virtualization changes a lot of things. We like to use hardware for security. We have TPMs in our laptops to protect the keys for encryption, things like that, and secure boot. But the virtual machine in the cloud cannot use the hardware directly. It's decoupled from the hardware. Now, the way we provide hardware functions to a VM is through virtualization. But virtualization is software. So how do we create a software construct with the same level of trust that we have in the hardware? It's a tough problem. In addition, VMs have a complicated life cycle. They get stopped and started, and they get migrated and maybe to another data center. So everything we do about security has to work in that environment and cannot obstruct the normal life of a VM.
The agility that people are looking for.
Exactly.
Yeah.
Now, cloud computing adds a complexity to that, because cloud computing is about very large scale, right? All the management processes are large scale. People, there is this phrase floating around the internet that we should treat our systems like cattle, not pets. Pets have names and you cuddle them, and that's not the cloud model. So as a practical example, if you have a database with sensitive data, customer account numbers and things like that, in the old world, you would put that on a machine and you would really watch over that machine. You might put it in a locked cage in a locked room, and you would watch over who can access it and so on. And that whole model conflicts with the cloud model, right? If we operate like that, we don't get the benefits of economics and scalability and availability and agility
The resource
of the
pooling
cloud.
and so on, yeah.
So we need to come up with techniques for security that fit with that cloud model and do not require hands-on care for an individual system. In addition, you have this sort of modern model of experimentation where we don't really plan and research. We build something quickly, we put it out, get feedback from the customers, respond, change things, and so on. And that goes against classical models of governance where you would have sort of accounting bureaucracy and you keep track of stuff. So we have to achieve, we can't relax governance, that's impossible. So we have to find ways to achieve governance within this agile model. It's a very interesting challenge.
Okay, so when we think about some of the threats and these industry trends and challenges that we've got, at a high level, what is Microsoft doing to tackle those challenges?
There is one element that adds a further level of complexity to it that drives our designs. And that is the third shift, which is the service provider model, right? Cloud computing is about large scale, but when you run in somebody else's data center, maybe Microsoft Azure, maybe somewhere else, we have now introduced a trust boundary between the tenant, the workload, and the fabric owner, the service provider. And our classical ways of working don't respect that trust boundary. So our solutions are very conscious of that. So we are doing a number of things to protect the tenant's workloads, including protecting them from the staff of the service provider. Because for many enterprises, the exposure to the service provider acts as an adoption blocker for reasons of compliance. Right? It's not necessarily that they distrust the service provider. You don't use Microsoft if you don't trust Microsoft. But for compliance reasons, they cannot extend trust to the staff of the service provider. And if we don't come up with good answers to these challenges, cloud will not succeed. So this is really critical. So therefore, we're doing a number of things to isolate using cryptographic technology to isolate the workloads from the fabric owner. We're also doing some interesting things to protect the workloads from direct attacks, because the direct attacks obviously have not gone away. And then the third element is just a matter of realism. We know that protection is never perfect, so we're doing a lot of things for detection and forensics. If you're being attacked, you want to find out about it. And you find out about it late, you want to find out what did they take, what secret documents did they steal, and so on.
And what can you do then to protect yourself going forward?
Exactly.
Okay, so that's 3 good classifications there around what we're doing with our solution. So if we start with that first one, that protection of those workloads, can you explain in a little bit more depth about how that works? Is this something that people could have experienced in Technical Preview 1 in Windows Server? Is that new? Can you explain a bit more about that?
It is. Variants of it could have been done before, but the really advanced solution we're doing now is new. It requires technology in the new platform. And what we've done is, when we speak about cloud computing, we often talk about the data plane where the workloads live, and a control plane, which is where you manage, where you start jobs and so on. We're adding a third ingredient, which is the trust plane. And the trust plane is isolated from both the control plane and from the fabric. So inside this trust plane, we can put sensitive functions like key management and all the provisioning of secret stuff. So using that technique, or that infrastructure, we can now do encrypted virtual machines, and we can have encrypted data, and we can do secure management. You know, there are people that say that crypto converts all other problems into key management problems. And in this virtualized cloud world, key management has to be done with sophistication to survive the new models. So that's what we're doing there. In order to create this isolated trust plane, we have a major new innovation that is coming out in Windows 10 for clients and in Server 2016, which creates a separate space that is a separate address space that is enforced by the hypervisor using hardware. So the platform uses the hardware, even though the VM cannot use it directly. And that gives us a level of confidence in that isolation that we have not been able to have before. And we can extend that confidence and that trust boundary to the tenant. So you can cryptographically ensure that your workloads are running here and the host or staff cannot get to it.
Right. So you mentioned this trust plane there. Is that something I would see in Windows? Is it something I can interact with? Or is it just something that's away from me and away from the OS, like you said? Is it just something that's secret, essentially?
Yeah. In effect, yes, you can see it,
right,
and you absolutely cannot interact with it,
right,
because it is isolated.
That's the whole point.
Right. So, and the reason we have confidence in it is that it is a small, tight area. We do not run Windows there. There are no device drivers. There's no network. There's nothing there other than a very small number of security critical functions. Mm-hmm. And on the Windows desktop, on Windows 10, we are putting certificate management. LSA is in there, and that will protect systems from many common forms of attack. In the data center, we're using it for things like key management and code integrity and other functions.
So there's a couple of things you also mentioned a few minutes ago as well around hardware. So is that hardware that exists today, or is that hardware we expect our partners to deliver in the future? And also the encryption that's now available to the guests, to the virtual machines, does that enable scenarios like BitLocker for encryption inside VMs, or is that something different?
Yeah. Yes, we are using BitLocker.
Yep.
And for Linux, we will use equivalent functions that exist in the Linux world.
Okay.
So we like that because BitLocker is proven and trusted, and we have used it.
Yeah.
With regard to the hardware, there are two answers to that. The first level of protection with this virtual secure mode and the encrypted VMs and trust management and so on, that's today's hardware. As any piece of hardware that supports virtualization, the hypervisor is a part of the story. However, we will also optionally support servers with a TPM and with UEFI secure boot. It's not required, but it adds to the level of trust because it allows us to make a statement about the integrity of the platform. If you send your work to a hoster, you would like to know for certain that nobody has gone in and disabled the crypto function, right? So with attestation, you can know that if those functions have been disabled, or if there is a rootkit on a server, the VM will never get decrypted. The system will not be able to decrypt it on a compromised host.
Right.
So that gives you an additional level of confidence.
So you're saying there that essentially, if I was to go and run a workload on a host that is known to be compromised, I wouldn't be able to place that workload there. It would be avoided?
Right.
Yeah.
Essentially, that host will not be able to get it. And similarly, if somebody steals the disk and takes the workload somewhere else, they can't decrypt it.
Because their host is not trusted.
Right. And if they steal a whole host and take it somewhere else,
Yeah.
they can't do it because key management is out of sync.
Yeah, because that host needs to communicate back to the management of the attestation service.
Right.
Yeah.
And you specify precisely which data centers are allowed to do this.
Right.
This also allows a customer to constrain workloads by national boundaries, right? Somebody might say, you have to keep this inside Germany or inside Norway and you can't run it to the US. Well, we can now do that
Right.
with cryptographic technology.
So I just want to confirm for people as well around that BitLocker support. So if I've got my Surface and I to enable BitLocker on my other laptop, it needs to have a TPM chip. How are we doing that in a virtual machine?
Yeah, exactly. Using a physical TPM is what we do on the laptop.
Yeah.
But the laptop, like I said, has a simpler life cycle than a
Yes.
virtual machine. So what we create using this trust plane, we can now create a virtual TPM.
Right, so like a VTPM.
A VTPM, and it serves the same function as the TPM in the laptop.
Right.
Except the difference is that the VTPM is mobile.
Right.
Right.
And does it require a physical TPM as well? Are we passing it through in some way, or are they completely separate?
They're separate. It doesn't require it. If we have a physical TPM, we can use it for extra integrity guarantees.
Of the host.
Right.
Yeah.
But if virtual TPM does not require that, it's a total software
So it
construct.
gives people a lot of flexibility, especially around if they've got compliance requirements to have encryption enabled in their workloads.
Yes. In fact, today I would recommend if you buy new hardware, you should buy it with a TPM, and a TPM 2.0, not the old TPM.
Yep.
But for everybody has an existing environment without TPMs, they can still roll out the functionality right away and then add to the level of integrity over time.
Okay, so when we think about deployment in Hyper-V, and you've mentioned secure boot a few times, that was a feature of a Generation 2 virtual machine in Windows Server 2012 R2.
Right.
Is the VTPM and therefore the BitLocker support going to also be a feature of a Gen 2 VM and not a Gen 1?
Yes, the full story that I've described here requires a Gen 2 virtual machine, which means it goes down to Windows Server 2012. We are also intending to provide encryption for Generation 1 VMs.
Okay.
So we can go down to 2008.
Okay.
And we are working out those details, and we're trying to extend the same level of trust to a Gen 1, even though we cannot use the VTPM. So we will have another way of protecting those.
Okay, so that's a good overview of what we're doing to protect the workloads. But what about, you mentioned before, direct attack? So what is direct attack to the guest or to the workload itself? Right.
That's a different situation, and that's the more obvious one, right? That if you are Contoso, a company running in Azure, Contoso can get attacked directly. It doesn't matter if they run in Azure or run somewhere else. And it happens all the time, of course. The central area we're looking at there is the vulnerability that comes from administrative accounts. if you look at all the attacks that have happened recently, there's a lot of discussion about how the people get in, how the attacker gets in, right? There are 0 days and spear phishing and this and that. But eventually, what happens is that they find an administrative account and exploit that.
Right.
And we think that it is going to be difficult or impossible to ever totally block the entry, because we know that social engineering works. People can be fooled. And we know that bribery works. And there are various ways. So admin accounts will get compromised. And the problem we have today is that when we built our system decades ago, all the environment, we gave the admin the keys to the kingdom. So if somebody can get an admin account, everything is toast. That's the problem we cannot tolerate.
Okay.
And so we have come up with a very important solution to that problem. And it is what we call just-in-time and just-enough admin. The idea is that instead of giving your staff totally unlimited forever privileges on the whole environment, effectively nobody has privileges for anything as a starting point. And then when somebody needs to work on a system, they go to a portal and they check out short-lived privileges. So they say, I need to work on the storage subsystem on that database machine.
Yep.
And you get privileges to work on storage on that database machine. And those will last 2 hours or 8 hours or whatever you set up. But that doesn't mean you can go to another machine. And it doesn't mean that you can do all kinds of other things on that machine either, because you asked for storage.
Yep.
So what this does is it contains the admin privileges. So if somebody manages to steal that person's account, it's limited to that area.
Yep.
In addition, it gives us auditing capability, and we can put up strong filters on that. We can require multi-factor authentication. If you want to, for sensitive assets, you can set up human approval workflows. Maybe somebody else has to come in and sign off. There are many ways that you can protect that. You don't want to introduce too much friction in the process, so that the CIO has to sign off on anything that's going to be done. That's obviously impossible. But you can set up policies that are reasonable for your environment. But in any case, it prevents that sort of unlimited spread across the environment.
Okay.
We think this is a very important thing. In fact, we have used it in-house for a very long time, in Azure and Office 365 and all these other systems. And we believe that without those systems, we would not have been able to achieve the certifications that we have gotten for Azure, like the federal US government and the European Union and credit card field and HIPAA and all of those. They require that kind of discipline. It just took us a while to figure out how to generalize that solution to all of our customers.
Okay, so let's assume the worst case has happened. We've had a breach. How do we go about using some of the Microsoft technology to A, detect and then analyze what's happened and help us respond more effectively going forward as well?
That's a key part of the solution. In fact, all the security experts I've talked to said, yeah, protection, we need detection. And we think, I mean, we've had intrusion detection systems before, but we think that the time is ripe now for a major revolution here. And the reason is cloud scale analysis, right? We have the ability now to instrument and collect an enormous amount of data. We can collect data from the fabric, from the workloads, from storage systems, from authentication systems. We can collect it from private cloud, from public cloud. We have our anti-malware team. We have a very active anti-crime unit. We have collaboration with industry partners and with governments. Vast amounts of data. And we now have the capability to process all of that data because of the cloud. Right? In the cloud, we can have a reasonable discussion about analyzing petabytes of data per day. 5 years ago, we couldn't do that. But today, petabytes of data per day is, I don't want to say it's easy, but it's routine. We have the capability to do that. And we have used that ourselves for many purposes internally. And then on top of that, we then add machine learning technology. And machine learning, as I'm sure you know, is, well, we've had it inside for a long time, and it's now available for our customers in Azure as well. So when you combine all the data and the scale and the machine learning, we think we will have a series of breakthroughs in detection. We have released 2 functions that are available now that do various forms of analysis and detection of attacks, forensic analysis, searching around, figuring out what's going on, showing you the
Patterns,
status.
things like that, yeah.
Yeah. These functions are available in OMS.
Yep.
And something we call advanced threat analytics, which is a separate
So
product.
two things that we learned about in the keynote. So the operations
Yes.
management suite, which was a new announcement we made, and also the analytics that you mentioned
Yes.
as well.
ATA was demoed in the keynote,
Yes,
in fact.
yeah.
A very nice product. So these things are just the first steps, because we have built up the foundation and the capabilities, and we're now looking at many different ways of leveraging that technology in the environment.
Okay, so is this detection, this analysis, is it only applicable to environments that are exclusively Windows-based on premises, or is it cloud, is it Linux? How flexible can we be for people?
It's been a key principle during this whole project to make things available where they need to be available, and make them practically consumable. So in almost everything I'm talking about, we are making it available on down-level systems and on both Windows and Linux. If not today, then very soon. We're working across this. This has been a core principle for the whole project. And it needs to be available in both private cloud and third-party hosters and in Azure, of course. It's been very difficult, in fact, because if you think of just-in-time admin, what we said up front is it has to support existing versions. It cannot require upgrading all the domain controllers. It cannot require reacting all your systems. It cannot require changing all of the processes you use for managing access. And the team said, that's impossible. And then we said, no, but that's what we need. And they grumbled a bit, and then they came back with a solution.
Right.
And of course, that means they have now lost all credibility. Whenever they say something is impossible, I'll never believe them again.
Very nice. So nothing's impossible. So from a Linux perspective then, in the cloud, am I deploying a Linux agent onto in the environment? Is that what we're engineering as well?
We are working with partners in that space. In some cases, we can add things ourselves. But as you've heard in our discussions, we support multiple distributions of Linux. And so we're working with partners. And just like we did with Windows, where we used BitLocker, which is proven, we want to use existing, proven, trustworthy crypto technology in Linux, and similarly with authentication and so on. So we're engaging with the ecosystem there to be sure we get solutions that are trusted by that ecosystem.
Okay, so going back to the workloads and the protection of those, when can people start using this today? Is it in the Windows Server Technical Preview that people can download now and start playing around with this?
Yes, all of these functions, the just-in-time, for example, is available in preview now. The Protect the Platform is available in the summer release of Windows Server in that preview. And very often what happens is these functions build on each other. So just-in-time is available now, and then the new version of Windows adds functionality to it. So this will be becoming more and more complete over the next year, in effect, as we roll out previews and then final GA.
Yeah, now one of the technologies that has been available for a while, or at least one of the components of the Operations Management Suite, was known as Operational Insights. That's been used for quite a few months in preview for a lot of people. What's the feedback been? What have your team and the surrounding teams learned from what customers have been learning themselves from the product?
It's been very successful. We've had it in preview for a long time, and it just actually went GA a month ago.
So generally available for people.
Generally available, right. And we've now added the security, what we call an intelligence pack, which is an area of solutions. We've added that. We're getting very positive response to that. And as I said, this is a work in progress. As we learn, we get feedback from customers, we learn from the attackers. So this is an ongoing thing. So you can use it today, but you should keep your eyes open, because new things keep rolling out on a rapid pace. Okay,
and is it easy for me to get going with that component? Do I need to deploy agents? Does it integrate with my existing investments in, for instance, System Center as well?
It's very simple, and that again was a top principle for us, to remove the friction. If you're using System Center already, it will integrate with that. If you're not using System Center, you can still hook up with Operational Insight and you get meaningful data there. And if you're running in Azure, it supports you as well.
Okay. So thinking about some of the things you mentioned before as well, before we wrap up, you mentioned host attestation, you mentioned the secure boot, and are all of those going to be managed by System Center, or are they going to be, is it PowerShell-based management? What options do people have?
The functionality exists in Windows, and it's available through standard techniques, PowerShell certainly.
Yeah.
In many cases, things like System Center automates a lot of the workflows. So it makes it easier for you, like, for example, to create an encrypted VM. Essentially, you just choose from a menu, and then your workflow is the same in System Center as creating a regular VM. If you don't have System Center, you can still do it, but you then have to take over more of the orchestration of the process that otherwise System Center will do for you.
Okay, great. So if people want to learn more, this week you had a session a couple of days back on that gave more depth about all this stuff. Was there any demos in there as well?
Yes, in the session yesterday we did demos, and then there's a whole series of in-depth sessions going on today and for the rest of the week, where people go into all the details that we can't do in a keynote.
Great. Okay, cool. Well, I guess it's time to wrap up. Thanks, Anders, for joining me. It's been a pleasure, as always, to learn more about security. Now, there's a hot session coming up next, and it's one you will not want to miss. So Jeffrey Snover, you may have heard of him. Andrew Mason, also on the NanoServer team as well, delivering a cool session on NanoServer, the future. It's a very bold statement. The future of Windows Server starts now. So definitely stay tuned to that. Thanks for joining us. It's been a pleasure to have you. Thank you.
Thanks.
See you again.